Hi, I'm Shalki and today I'll be telling you about the automatic image annotation problem. So the goal of our assignment was to assign some labels, some textual labels to a particular image, and the objective of this assignment was to actually get familiar with the fundamentals of machine learning with the nearest neighbor methods and the metric learning, then even know about the issues in machine learning and reproduce the results if the codes are already given to you. So here we had a data set, and the data set was the Coral 5K data set, and this data set has two data basically, and that is the train and the test data. Our train data consists of 4500 images and the test data consisted of 499 images. This Coral 5K dataset was again actually used, and we calculated the features for this dataset, these images basically, and we calculated two types of features for that. First one is the feed 2, where we calculated the basic features for these images, and those basic features were the features such as the color, shape and texture features, and using each of these features pairwise distances were computed for the samples then. And the other one, that is feed 2, that is the embedded features, and that was calculated by combining all the basic features, and then a single feature vector was computed for it, and this was then used for computing the single pairwise distance matrix for feed 2. And we tried with three nearest neighbor approaches for the image annotation problem. They were JEC, TagProp and 2pkNN, and we even tried some of the variants of those approaches. Like for TagProp, we tried with TagProp SD single distance, TagProp Sigma SD, TagProp ML multiple distance, TagProp Sigma ML, and we were supposed to perform 8 experiments using different combination of these variants for feed 1 as well as feed 2. And the performance evaluation measures that we are using are precision, recall, F1 score and N+. N+ is the number of labels with positive recall. So we performed the run on using these three approaches on the Coral 5K dataset using feed 1 as well as feed 2, and the results what we got were consistent with their respective papers, and the best results what we were getting was for 2pkNN. 2pkNN actually is the state of art for image annotation as of now, since it was released. And for feed 2 we are getting better performance. That is because feed 2 is actually combining the basic features from feed 1, and a computed matrix is found on the basis of analysis, and it is a long time thing which someone has done and found out the main features from it, so it performs a bit better than the feed 1. Next thing what we were supposed to do was to find out the role of validation in training data. So the validation in training data, the role of them is to basically predict the parameters which would give the best performance for the validation data, and if it is giving the best performance for the validation data, then we also assume that it would perform best for the test data. So we found out those parameters. We want to find those parameters which will perform best for the test data, and that is why we use the validation data. And if we have a larger validation data set, then our model will not be able to get trained on a wide range of all combination of the labels for the images. So if our validation set is larger, then performance will be lower and it will not give us the best parameters which would perform best for the test data. Next, we were supposed to uh, analyze on the per label performance for the individual labels. So first we were supposed to plot a line plot for label frequency using training data. So as we can see from this plot, there were some labels which were very frequent in the training data set, whereas there were many labels which were rare, which were rarely used in the training data set. So that is why those rare labels could be thought of as a noisy data, and if those data are removed, then we can say that we can get a better performing method. Next, we were supposed to plot the per label performance that for each of the 8 experiments and plot their precision recall. So that won't give a better analysis as such. It was just to plot them. Next, we were supposed to do the qualitative analysis for different variants of these methods under different settings, obviously. So we were supposed to do for V1, V3 and V6, that is for JEC, TACPROP, Sigma SD and 2pkNN using feed 2. So here I have given an example for 2pkNN, where 2pkNN was performing better than JEC and TACPROP Sigma SD. So these were the 5 images, 1098, 21072 and the other 3, which were actually giving better results with 2pkNN than JEC and TACPROP Sigma SD. Next, we were supposed to find and analyze on the class imbalance basically. So what we saw earlier was per label frequency in the training data. Here what we are trying to do is we are trying to divide the labels in bins and then plot the frequency of those bin labels. And we were even supposed to plot the performance for each of the 8 evaluation experiments for this, so that we were basically supposed to plot the precision recall and F1 score for each of the 8 evaluation experiments on the basis of these bins for the labels. Instead of having that for each label, having it for each bin. Next task was actually to randomly remove labels from the ground truth of the training data. So we were supposed to randomly remove X% of the labels from a particular training image. So if a training image has suppose P labels in its ground truth, then we were supposed to remove X% of those labels from those P labels of that image. And this I had to perform on the 10% thing. So I was supposed to remove only the 10% of the labels from the ground truth of the images. So that thing did not make a big change, as 10% of removal of the labels would only remove at max 1 labels, that too also from very small number of train images. So this did not make a change in the performance. Next thing what we were supposed to do was actually to shrink the train and test data set by only considering the 75% of the most frequent labels that were occurring. So we only considered the 75% of the most frequent labels from the 260 labels that we had, and using those labels we were then supposed to again train and test it on those labels. So we removed some 25% of the labels from the data set, and even we removed the images which did not consider any of these 75% of the frequent labels. So we removed those labels which considered those 25% of the rare labels from the train as well as the test data. And obviously removing those rare labels would perform better because those rare labels was very infrequent in the data set, and it was actually performing the task of noisy data in our data set. So when we remove that, the method performs a bit better. So, and we can even see that precision recall increases, but our n plus, that is the number of labels with positive recall, that decreases by a very small amount. The next task was to actually again shrink the data by only considering those 25% of the rare labels that we removed initially. Now we are considering those 25% of the rare labels, and using those 25% of the rare labels we are training and testing again. So for this we could say this as a very bad method of doing, because those labels are very rare, and uh, performing it on those labels only, that would actually be bad and it would perform bad because we have a large set of data and those labels occur very infrequently. So here we could see that our precision and n plus, both of it decreases, whereas our recall remains almost kind of the same. The last part of the assignment, that was actually to, for my part it was to demonstrate the image annotation problem using any of decision tree, neural networks and SVM. So I have done it using SVM, and I have followed the one versus rest approach of SVM and trained the model for each label and predicted the probability for that model, and at the end calculated the performance of these labels obtained. So when I did this for feature 2 using SVM, so I was getting a F1 score of 0.33 and N plus of 170, which was quite decent, not very good. So the summary of this assignment is actually we were supposed to do nearest neighbor methods using multi-label classification and metric learning. And we also learned about the basic machine learning techniques which I used, and how to work on an already available code. Thank you.